constant head permeability test was conducted on a soil specimen under a hydraulic gradient of 2.5. The soil specimen has specific gravity of 2.65 and saturated water content 20%. If the coefficient of permeability of the soil is 0.1 centimeter per second, the seepage velocity in centimeter per second through the soil specimen is. Okay, let's note down given data first. So hydraulic gradient hydraulic gradient, which is denoted by I, is given 2.5. Okay, specific gravity which is denoted by G is given 2.65, and saturated water content, remember it is saturated water content is 20%. Then SR, degree of saturation, is 100%, that means 1 because it is saturated. Then coefficient of permeability of the soil, coefficient of permeability of soil, which is denoted by K, is 0.1 centimeter per second. Then what should you find out? What is seepage velocity? Seepage velocity denoted by small v suffix a. Okay, first see, according to Darcy's law, we know that velocity, laminar flow velocity, is proportional to the hydraulic gradient, then directly proportional, then v equal to velocity, this is k multiplied by I, where v is discharge velocity, it's not seepage velocity. Okay, I is hydraulic gradient, k is permeability of coefficient of permeability of soil, which is constant. Now to get this, we have been given data. What is k? K is 0.1. What is I? I is 2.5. So it is 0.25 centimeter per second. V, discharge velocity, is 0.25 centimeter per second. But we need seepage velocity. See, what is seepage velocity? What is discharge velocity? Let us say a soil. Okay, let us take a soil of cuboid section. Okay, the flow is happening in this direction. The water flow is happening in the soil. Soil has some soil grains. Okay, there are voids in it. The voids are interconnected. That's why the water can flow from here to there. Okay, so really the water is flowing through the voids, right? See here, full area of cross section. If you take area of cross section A, this is total area of cross section. Whereas if you see as the water is flowing only through the voids, so AV, if you take AV, it's area of cross section of voids, only voids area, this only voids area. If you take that, that is area of cross section of voids area, that is AV. But here, discharge, whatever water which is collected here, which is flowing from here, the collected water, if you take it as in terms of discharge, so discharge is generally denoted by Q. This Q is meter cube per second. So how much volume of water is collected in a particular time, that is called discharge. So that discharge is calculated using area multiplied by velocity. Okay, area multiplied by L. Area of cross section, if you take total area, you have to use discharge velocity. Okay, this is total area and this is discharge velocity. Okay, whatever with which velocity is it is discharging, that is called discharge velocity. That discharge velocity you can calculate using this. We have calculated that. And area, if you take total area, then you will get discharge. But the same discharge can also be calculated by using area of voids only, but you have to use velocity through the voids. Vs is seepage velocity. This is nothing but velocity of water through voids. This is velocity of water through the voids, seepage velocity. So you have to use that velocity through the voids because you are using area of voids, but discharge is same. Okay, now this is 2, this is 1. So here from 1 and 2, you can write A into discharge velocity AV multiplied V. So discharge velocity is like this, total area. Now I need discharge velocity, right? AV by AV by AV, where AV is voids, area of voids, A is total area, V is discharge velocity. Now I can write discharge velocity divided by area of voids by total area. Okay, see, the length is same for voids and for total soil, the length is same. Okay, for a particular length you just multiply it by length, AV multiplied by L, A multiplied by L. Okay, it's nothing but A into L is volume of capital V, volume of voids divided by total volume, because total area into total length, total volume, area of voids into length, volume of voids. Now if you see, Vs equal to discharge velocity multiplied divided by volume of voids by total volume is nothing but porosity of the soil. Okay, now what is porosity? Now you know this is 3. What is seepage velocity? We understood to discharge velocity by porosity. N is porosity. It is also calculated by using void ratio. But how to calculate N? We know W 20%, it's 0.2, and G 2.65, SR equal to 1. Implies E is WG 0.2, isn't it? 0.2 multiplied by 2.65. How much? It's 0.53. E is 0.53. Then what is N? 0.53 by 1 plus 0.53 divided by, you will get 0.3464. Then what is seepage velocity? What is discharge velocity? Discharge velocity 0.25 centimeter per second. 0.25 centimeter per second divided by 0.3464. Okay, it's 0.7216. Therefore Vs is 0.72 centimeter per second. So what is 0.72 centimeter per second? Answer is 0.72 centimeter per second. Thank you.